Hello. How's it going, everybody? You guys all doing well today? You guys excited for midterms to be over? Yes. How did midterms go? Like, can I get like thumbs up, thumbs down? Like, okay. I know some of you guys have a GCIS 1, 2, 3 midterm on Monday. So we'll be doing a little review session on Sunday. If you want to come and review all the concepts, it'll be run by yours truly. And I promise I know what I'm talking about, for sure. Oh, yeah. But for today, I'm talking about the uncomplicated firewall. And we'll be uncomplicating it even more. So that way, all of you, if you have to set up a firewall on a Linux box, you can do it. And do it at a pretty good level. So without ado, let's get started. So first, I want to talk about the OSI model. Who can tell me a layer in the OSI model? I'll give you a hint. They're on the screen. So, yes. Physical. Very nice. What's the next layer in the OSI model? Anybody? Data link. Data link. Yo, over here, what's the third layer? Network. That's wild. Over here? Fourth layer. Transport. Cool. Chase. Fifth layer. Session. Good job. Behind Chase. Yes, and the last layer is the application layer. So with the universal firewall, we can write rules for most of these layers. All of them except for layer 3 and below. So we can write rules that block ports and define traffic. And we can actually do some traffic shaping, which is a fancy term for like using a firewall, traffic shaping for layer 3, but it's a bit more complicated. So we'll leave it as uncomplicated as possible for today. So another little primer on the Linux network stack. I'm gonna do my best to make it pretty simple, but basically, it's like take all of this thing right here and call it one thing and call it the wire. And traffic's gonna come in off the wire. It's gonna get picked up by the kernel, which is like most Linux implementations use netfilter for their networking kernel like module. And then we get parsed through the TCP stack, and then it's sent into user space where like we'll see it. So if you have like a web packet come in off the wire, get picked up by netfilter, get filtered by anything that's like any rules that we've got written for that, and then go all the way up through the sockets and into the user space, so where we can see it in a browser. So that's kind of how this works. The stuff we're going to be using with UFW is we'll all be applying in like this net filter through socket layer stuff. That's kind of where that sits, which is pretty cool. So Linux firewalling, as we just said, packet will come in off the wire, get picked up by the NIC, which is a network interface card. Then it'll get passed to the kernel, which is netfilter. After that, it'll get parsed by will get parsed by firewall rules, in which case it's IP tables, then sent to user space, and that's where we can see it. So UFW is an abstraction of IP tables. So IP tables is a utility that is being used to write rules for netfilter, and it's actually being released by NF tables for like the future. So if you want to get ahead of the curve, go look at what NF tables are, get used to those, because that's what's coming. But for now, IP tables is where we stand. I have a talk about IP tables that I did about 2 years ago, and I was going to link it in the resources, but then I forgot that I wrote this slide, and I said I was going to link it, so I didn't do that. But when I drop these slides, I'll also go drop the talk about IP tables, and it'll be amazing. So yeah, UFW is a front end for IP tables. So under the hood, we're all doing the same thing. So if you don't like the restrictions that UFW has because it's more simple, then you can use IP tables, and it'll be just the same stuff. So now, how do we use IP table? How do we use UFW? So the first thing you got to do is you got to turn it on. You do UFW enable. If you want to turn it off, you do UFW disable. And all of these are privileged commands, so you're going to have to run sudo or be the root user and all that good stuff. So you can turn it on and off, then you can reload a firewall rule. So you add a rule, you want to reload it to make sure that it's like actually applied. So you do a UFW reload. And then if like everything's wrong, you can do UFW reset. It'll reset everything to installation defaults. You get like a clean slate and you start all over again. Any questions so far? I didn't lose anybody? Sweet. I lost Malik. He left. That's pretty sad. Some more UFW controller commands. So we can have some logging with UFW. I can't see my notes, so I'm going to have to go off memory here. When you have UFW logging on low, it'll just log all of the packets that get blocked by your rules, and then everything that you have, like you can have like a logging tag on a rule, and so every rule that packet gets applied to will get logged as well. So by default, low, that's a default. Anything with medium or above uses up a lot of disk space, so only do that if you like really have a big disk. Otherwise, you probably use up all your resources. Medium is going to log everything that gets matched and accepted by default like rules. And we'll talk about default rules in a moment. Well, actually, yeah. And then high will do everything, including routes and everything that's not being rate limited. And then full does everything that is being rate limited. Again, you're probably going to be good with low if you want to log all your stuff. So by default, UFW sets policies for directions of traffic. So you have incoming traffic, outgoing traffic, and then routed traffic that's being passed through your box if you're using a box as a proxy. So you can set the default policy for each of these directions using UFW default, deny, allow, reject, then your direction, and it's pretty cool. You can also use UFW status. You can either do verbose or numbered to get all the information about your rules and the state of the firewall if it's like enabled or disabled. So now, let's write some rules. So to keep it pretty simple to start out, we can do a UFW allow port. So we can do like UFW allow 22 for SSH. We can specify TCP because SSH uses TCP. A little quick question. Does everybody know what SSH is? Everybody not know what it is? Cool. Everybody know what TCP is? Hopefully you guys should know what that is after Weissman's networking talk. Can I get a yes, Chase? Yes, that is what SSH is. What does it do? Exactly. Good job, Chase. What is round two? What's TCP? Yeah. Well, I think it's transmission control protocol, but you're off by like a little bit. So what's its features?
It makes sure it sends the packet as a three-way handshake.
Yes. Good job. So yeah, we can specify ports and protocols, and we can also do this little thing called use a service. So does anybody know what the etc services file is? Ross, you want to explain what the etc service file is?
Where all the services live.
Yeah, basically. Pretty self-explanatory. So if there's a service listed in etc services and it has a port next to it, you can use the name of that service in your firewall rules. So SMTP, it's a simple mail transfer protocol. Well, protocol transfer, something like that. It helps with mailing stuff. It's also used with IMAP and IMAP POP3 and all that good stuff. Mail's complicated. Anyways, we can use like SMTP instead of having to specify the port, which I believe is like 135 or something like that. Again, SMTP and mail is complicated. We can also specify directions for traffic and firewall rules. So if we want to allow in HTTP but not allow out HTTP, we can just have a UFW allow in HTTP like rule. Or we could block incoming SSH but allow SSH to go out. So we could do like UFW allow TCP in or TCP port 22 out, stuff like that. We can also do denies and rejections. So we'll talk about those later, but we can substitute in from these commands. We can put in reject and like all this other stuff, or we can put in deny and all this other stuff, and it'll work just the same. We'll just do that action instead of allowing it. So now to make it a bit more complicated, anyone want to read this and then tell me what it does? Seeing no takers, it's okay. It's complicated. So this kind of gets into like the syntax that packet filter uses. So here we have Ufw Deny, so we're blocking this traffic. We're just going to drop it. Then we're specifying a protocol, proto TCP to any destination. So this is an IP address, port 80. So basically we're blocking TCP traffic to port 80 to any destination inside of our host network. We can also specify a from. So we can do Ufw Deny protocol TCP from anything in this subnet to any, for the destination is anything in this subnet on port 3306. What is port 3306? What's the service? Everybody know? Yes, it is. So this thing is blocking all MySQL traffic. Well, anything running on this port, all traffic that's destined for this port, coming from that subnet to this subnet, and it's wonderful. This is the same syntax that packet filter uses. So if you're writing like packet filter rules on like a pfSense router or an OpenSense router, like anything that like BSD, it's the same syntax. So that's pretty cool. If you saw, you could use service names instead of ports. So we can use Ufw app list to get a list of all possible service names that we can use, or you just check out Etsy services, and it's all the same information. You can also do, if you make any changes to Etsy services, you can use Ufw app update to get information about it, and info gives you more verbose information on all that good stuff. So deny versus reject. Deny is going to drop your traffic quietly, just kind of ignore it, like Malik does to my DMs. But reject is like you're gonna basically communicate with the sender that you're dropping all the traffic intentionally. I forget the exact implementation of this like in TCP, but it's definitely something that you can pick up with like a Nmap scan or different variations of Nmaps, like the Christmas tree or like the fin scan, all that good stuff. This is really up to your discretion. It's a kind of like a nuanced thing about like why you would want to deny versus reject traffic. So I'll let you guys peruse that at your own interest. So some defaults, because everything has default behavior, and understanding how the default behavior works is the starting point for writing good firewall rules. So all rules will be applied to all available interfaces by default. So that's why we need to do like our directions. So we can say like in or outgoing or routing and all that good stuff. And rules are going to work on a first match basis. So we have like a rule set that's like 50 rules long. The first rule that the packet matches on will be the thing that it gets applied to. So if you have a deny all at the start, all the traffic is going to get blocked. If you have it at the end, then all of your other rules will get parsed first, and if it doesn't match on any of those, then it'll get dropped. So just kind of remember that when you're writing out your scripts and all that good stuff. So some rule management. If you make a bunch of rules, you probably want to make sure that like they're all in some sort of order. So you can use Ufw status numbered. As you can see here, we got a little screenshot. We've got like 6 rules. This is for ELK. This is SSH. This is more ELK stuff. Well, this is IPv6 stuff. So yeah. But then if we wanted to say delete like rule number 6 because it was bad, we could just use Ufw delete. We specify the whole rule that we used to make it, which was just allow in TCP the rule was allow in 22/TCP. We could just do, instead of like having to remember what the rule was, we just use the number here to delete that rule specifically. So we just do like Ufw delete 6, and we're gonna get rid of it. And we can also insert a rule at a position. So we just specify the number and the rule, and then it gets inserted at that position. So if you need to like modify something at the top of your list, if you don't want to rewrite everything, you can use that, and it's pretty sweet. By default, when you make a rule, it'll be appended to the end of the list, not the top. So that's where insert comes in very handy. I'll take some water, and we'll talk about why this is important. Okay, raise of hands, who is blue teaming at IRSec? Malik, why is your hand in the air? You guys aren't blue teaming at IRSec? Yeah, okay, cool. So do you guys have, actually you don't have the packet yet, but you're gonna have some boxes that exist in a remote network that you're not gonna have console access to. So what would happen if you wrote some firewall rules for those boxes that denied all incoming traffic for SSH or RDP or any favorable connection method? What would happen? Yeah, you would lose connection to your own box, which, I don't know about you, that sounds pretty bad to me. So what we do when we're writing firewall rules to make sure that we don't have any errors in our box, like in our firewall rules, is we do a little thing called Ufw reload, then sleep for 20, and then drop all the rules. So this is hopefully this is stuff in your script, so you just have that at the end of your script. Basically, you'll load up all your rules, then you'll give it 20 seconds, and if your shell hangs or you drop the connection, don't worry, because you have a little reset in there that's going to drop. Well, you have it disabled. It'll drop all the rules, so you'll still have access. That's your little testing mechanism to make sure that you're not going to firewall yourself off. If you don't do this, and then you do apply the rules, well, you kind of firewall off from your box. That's a big L to take right then and there. So make sure you guys do that, or at least you test your rules. The way to test your rules is using Ufw tactac dry run. So you can append this to the start of any Ufw command, and it'll show you everything that it will do when you actually do it. So that's a good way to test if your rule is going to make sense or not. So you can use Ufw dry run, deny SSH traffic, and then it would be are you sure you want to do this? And then you'd be yeah, and then you SOL. Or you could say dry run, and you'd be, are you sure you want to do this? And you'd be oh wait, I'm using my brain real quick. No, I don't. And that's a pretty good way. So in short, be smart about where you write rules and what you're actually doing, because it's pretty easy to log yourself out of boxes. So putting it all together in a little script, and then if I have time, I'll do a little demo. I don't really have any time. So what do these rules do? Anybody? Nobody? Okay. Yes.
You're allowing SSH and HTTP and HTTPS traffic out.
Yes.
Crazy.
So this is actually a really simple rule set, but if you have a box that is only being scored on HTTP or SSH, you could then add a rule down here that just denies everything else, and then you're good to go, assuming that it's in the LAN and you only want to allow stuff out. So writing firewall rules is not complicated. It does not take a long time, so you should definitely do it. I was trying to find an example of ICMP traffic, and I realized, I looked it up, that it's more complicated because the Ufw doesn't have any stuff to do with ICMP by default. So what you're going to have to do if you want to write ICMP rules with Ufw is not use Ufw and use IP tables, because you can do that. Or you can go and modify this etc Ufw before.rules file, which is when Ufw runs everything, this file will get checked before everything else gets checked. So there's a couple of other files like this, but we're going to keep it uncomplicated. So you can just add this thing, which actually has IP table syntax to that file, and then it will allow everything for ICMP through. This whole string will make more sense if you go watch my IP tables talk, because we talk about what all of these different flags do and all that stuff. But I can give you a little rundown. Give me a phone call. So this little TAC piece has protocol. Protocol is specified as ICMP. This M stands for match, we're matching on state, and then we specify what state we want. So we can either do new, well, yeah. Yeah, so we're matching on new, established, and related state. So that's like, except that will allow you to send out like ICMP requests and get echo replies back in. And then this tag J stands for jump. So we're jumping to accept. And we can also like jump to deny or reject. That's kind of how iptables works. And then tag A stands for add/append. So we're adding it to this chain, which is right here, and that's where it's going. So that was a lot about iptables. Make more sense if you watch the talk. Here's some resources. So I used the top one to write this entire presentation. So it's not too terrible. And then this is where I got this last thing from. So here's some resources. I'll drop the link to the YouTube presentation that I have about iptables as well. And I'm also just around. So if you have questions about it, let me know. Questions now?
Would you say this stuff was helpful for IRSec and UV lockdown networking?
Oh, it's so helpful. Little follow-up question. Can anybody tell me why we should have host-based firewall rules and network-based firewall rules? That's not Braden. All right. If no, yes, you go, and then we'll go to him, and then you'll be the conclusion. Okay, one.
Your router could be compromised.
Yes.
They could mess up your router firewall rules.
Okay.
A lot of competitions use switches in between the router and the host, so the host can talk to each other without hitting the router at all. So the router firewall rules don't work.
Okay. To recap for the stream, first thing we said was your firewall could be compromised, so those rules might get messed with. Then we said oftentimes there's a switch before the firewall, so all the hosts in the LAN can talk to each other before they get routed through the firewall. And Braden, take us home.
I mean, those are both good points. I don't really know what else I could add, but like lateral movement, which is kind of a switch thing.
Yeah.
Also, it's just another layer of defense. So you can pour more finely grained to it.
Yes. So Braden, to cap it home, cap it off / send it home. That's what I meant to say there. Said pivoting and lateral movement can be like defended against at the host-based firewall rule level, and also just like it's a good thing to do because as best security practice. So.
What kind of firewall rules would you want to make for like UV lockdown?
Yes. So in general, you should only allow out things that you need for scoring, so like trusted services, and you should probably have some firewall rules to allow like connections to remote boxes using trusted protocols, and then you should probably block everything else. If I was a blue teamer, that's what I would do. But I'm a red teamer, so I'm gonna make sure all those firewall rules say nothing. It's always empty. Question in the back, then up front.
What if I'm on Windows and I want to make a firewall?
That is a wonderful question. You can use this little thing called Google Windows Defender Firewall. And then you can find some resources called from the msdn.com website. And maybe it's not a .com, maybe there's something else in there. But honestly, I don't really know. I am planning on doing a presentation about it at some point. And so when I've done the presentation, I'll answer your question honestly. But for now, I'd say Google. Up front.
UFW is pretty uncomplicated.
Yes.
What are the advantages technically, other than just being not complicated, using UFW as IP tables?
That is the advantage, is the non-complication thing. You can do much finer grain firewalls using IP tables. Like you can match on state, like we have right here. So you could write a firewall rule for SSH that allows like outgoing new connections, but only allows like established new. Oh, actually, the other way around. You could allow in new connections and allow out established connections. That means that you wouldn't be able to establish new connections originate from this host, which would be good if you were like on the cloud. You want to allow incoming, but not any outgoing, which means that you can't, like a red teamer couldn't pivot from that cloud host because you're blocking from the host level. So this, like I said, UFW is like it's like a front end, very simple for IP tables. You're running everything the same under the hood, but there's a lot less complicated stuff about it. Exactly. Any other questions? Well, I'll be here all day if you have them in the future.